In this problem, we've got a stone that's catapulted from ground level at an angle of 38 degrees to the horizontal. If the stone hits the ground 27 meters from its point of projection, find its speed of release and the time it is in the air. Okay, so let's draw a little diagram just to visualize what's going on here. Okay, so the stone is catapulted with an initial speed, I don't know, of u meters per second. I know that it's catapulted at an angle of 38 degrees, okay, and that it's 27 meters from its point of projection when it hits the ground. So I know that's 27 meters, okay, where that's 0. So this is the information I currently have, and I need to work out u and the time it is in the air, the total time it's in the air. Okay, so let's think about using the SUVAT equations in the horizontal and vertical directions. So we're going to have x and y, little table, SUVAT, okay, so what do I know? Well, I know that I'm not accelerating in the horizontal direction, and the only acceleration is minus 9.8 in the vertical direction, okay? The initial velocity in the horizontal is u cosine 38. And the initial velocity in the vertical direction is u sine 38. Okay. I don't know the final velocities. I do know that I'm going to reach 27 meters. Okay. So the final velocity that I might consider, the final y coordinate will be 0 when x final displacement is 27. Okay, so well, I could put 27 in there. Okay, I don't know the final velocity, I don't know the time. Okay, but I can also utilize the fact that at that time, if I'm working with the same time here, then the s here will be 0 for y. Final velocity I don't know, the time I don't know. Okay, so if I want to find out, if I've got the s, the u and the a, then what I can utilize here is I could use this equation here, because I know when a is 0, I know the s and I know the u. Okay, the only thing is I don't know the actual capital U, that's speed. So if I utilize equation number 3 for the x coordinate here, for the x direction, okay, then I will have the 27, the s, is equal to u, so u cosine 38 times t plus a half times at squared. Well, a half times 0 times t squared is just 0. So I then know that 27 is equal to u cosine 38 t. So that's given me one equation. Now, can I use the same format to get another equation? Okay, so if I use number 3 for the SUVAT again, the s is 0. Now this is for the y, the vertical direction here. And I've also got the ut, so u sine 38 t, plus a half at squared, so minus 4.9 t squared. Okay? So this is what I've got. Now, looking at these two equations, I've got two unknowns and two equations. And it looks like to me that I could work out u first, I think. So what I'm going to do is I'm going to number that equation number 1 and that one equation number 2. Okay, I don't really need any of this anymore, because I've got two equations. I just need to solve these simultaneously. So if I rearrange number 1, I can get that to u equals. So u is equal to 27 over cosine 38 degrees t. Okay? Now if I substitute that into equation number 2, then I'm going to get 0 is equal to, I've got 27 over cosine 38 degrees t times sine 38 degrees t, take away 4.9 t squared. Now the t's here will cancel each other out. So this now gives me something I can work with. So I've got 0 is equal to 27 sine 38 over cos 38, take away 4.9 t squared. So if I add the 4.9 t squared to both sides, divide by the 4.9, so I'm going to have 27 sine 38 over 4.9 cosine 38. Okay, this will allow me to find t. So 27, so making sure you're in degrees, so 27 times sine of 38 over 4.9 times cosine 38. That's 4.305, so I want to square root that, and I get 2.074859814, so 2.1 seconds to two significant figures. Okay, so that is actually how long the stone is in the air. Now, as for the speed of release, I can now substitute that into this equation. So u is equal to 27 divided by cosine 38 degrees times by the 2.07, etc. So 27, keeping it in your answer key, cosine 38 times answer key is equal to 16.51364, etc. So 17 meters per second to two significant figures. Okay, so that is how we can work with the SUVAT equations to find the time that the particle's in the air and the initial velocity, well, the initial speed.